Good morning, students. It's me, Mehaboob. I am your chemistry teacher, and hope you are all safe in your home. So we will begin with a new chapter in 9th standard. The first chapter is matter in our surrounding. Matter in our surroundings. So, as we look around, we can see many types of substances. See, the air we breathe and the water we drink, the shirts or clothes we wear, and the chapel and bench, desk, everything. Even the planets, then the trees. So, what are the things? All are what? It is a matter. It is a matter. So, what is a matter? I think you heard about what is matter. So, all these substances, in order to occupy these substances, they need what? Some spaces, and they also possess some masses, isn't it? So, what is a matter? Anything which occupies space and has mass, that is called a matter. Anything which occupies space and has mass, that is called a matter. So, this matter here different scientists, they have classified this matter mainly into two categories based on the physical nature and chemical properties. They classified into two categories matter. So, here in this chapter we will discuss the physical nature of matter, and the chemical, based on the chemical nature, matter can be classified into some other categories that we will discuss in the preceding chapters. Here we will discuss about the physical nature. Based on the physical nature of matter, we can classify matters into different categories, not their properties. We are discussing about the properties of matter. So, physical nature of matter we are discussing. So, here when we discuss the physical nature of matter, let us see, we can take in olden days they were believed that matter, some are believed that matter is a continuous substance, like a block of wood, and some others believes that matter is made up of particles just like sand. So, they were believed in these two manners. That is, some of them may believe that matter is continuous just like a block of wood, and some others believes that matter is made up of particles. So, let us see, say take an example. If we take some water in a beaker, then you add some amount of salt or sugar, then before adding salt or sugar, you just notice the water level. For example, if this is the water level before adding salt or sugar. Then after adding, you just notice the water level. You can see that the water level may be slightly increased. It may reach here. But when you are stirring or without stirring, if you are keeping there for a long time, or if you are stirring that and it allow to settle that, after that you can see that the water level again reaches the original level or the initial level. So, what is happening here? So, what is we have taken water and we added salt or sugar, and then if we are stirring that, you can see that the water level remains the same. So, where this sugar or salt particles goes? Where it disappears. So what is the here? The salt particles, they get into the space between the water particles. Here water is there, in between the water molecules, in between the water particles, many spaces are there. In that spaces, these salt or sugar molecules, they get into the space between the water molecules. So here it means that what? The particles of matter, the matter is made up of particles. Why? Because salt or sugar particles, they are made up of millions of particles will be there, and that particles is getting to the space between the water molecules. So it is not, so matter is not a continuous thing, it is particulate. It is particulate. It is particulate. It is not continuous. So that is the first thing. So matter is not continuous, it is particulate or particle nature, or matter is made up of particles. Matter is made up of particles. That first one. The second one, how smaller are these particles? How smaller are these particles? So in order to explain this, we can take, okay, I have some water. See, I have taken some water here. See, this is a boiling tube, what a bigger test tube, that is called a boiling tube. So, and here I will take, I also have some, you can see this is called potassium permanganate. You can see this potassium permanganate, some very few amount I have taken, and I am just adding. See, you can see these particles, it is very little amount. So I have taken very few potassium permanganate into this boiling tube, and see, after mixing, see, you can see the color, it is pink color, isn't it? So I have taken very few amount of what? Potassium permanganate, that is potassium permanganate. Potassium permanganate. So I have taken some water, and into this water I have added some amount of very few crystals of water, potassium permanganate. Now you can see the color. Again, see, I am taking very few amount, for example 10 ml of 10 ml from this, and then again I am adding some more amount of water. You can see again the color exists, isn't it? Then from this I am taking again very few amount of 10 ml from this test tube. See, then again I am adding water. Still the color remains, or still the color exists? Yes, the color exists, but what? It is somewhat the color is fading, or the color is become lighter. Again I am taking some amount of, I have taken a very few amount, that is 10 ml from this test tube again. See, again I am adding water. See, again the color is there, but it become light, isn't it? Lighter and lighter. So if we are doing this 8 to 10 times, the color decreases, isn't it? It means that, why that color? The color is due to the presence of potassium permanganate, isn't it? It means what? It means we can even 2 or 3 small crystals of potassium permanganate can be divided into millions of particles, and due to the presence of that particle they give the color, isn't it? So, it means that particles are made up of very small, very minute, or we can say that the particles of matter is very small. The particles of matter is very small, and that is beyond our imagination. That is beyond our imagination. It is very small. So, even 2 to 3 crystals of potassium permanganate can be see in the color, or if we are dissolving that small amount of potassium permanganate in 1000 liter, we can see the color. It means that they can be divided into millions of particles. So, it means the particles of matter are made up of very small particles. Matter is made up of very small particles. So, that much smaller will be the particles of matter. First one is the matter is not a continuous, the particles of matter is not continuous, it is particulate, or the particles, the matter is made up of particles, and it is not continuous thing, it is made up of many particles. And other one is the particles of matter, the particles of matter is very small, it is very small. So, these are the physical nature of matter, and based on this physical nature of matter, we can discuss the characteristics of particles of matter. Characteristics of particles of matter. See, this experiment, that is, we have dissolved, we have taken potassium permanganate, and then we keep on dissolving to, so if we are taking some amount from to other test tube containing water, then again it will give color. Now, the same experiment can be done with the Dettol. You take some Dettol and then take dissolve in 100 ml of water, and from that Dettol you can take 10 ml and again dissolve in another 100 ml of water, then you can see whether the smell is there. So, the same you can repeat that experiment to 8 to 10 times. So, that smell will exist. It means what? The same observation, that is, Dettol is made up of many small particles. So, that is the another example for the particles of matter is made up of very small particles of matter, or matter is made up of very small substances. Now, the characteristics of particles of matter. What are the characteristics of particles of matter? First one is that particles of matter have space between them. First one, particles of matter have space between them. Particles of matter have space between them. So, here this we have already discussed just before, that is, when we dissolve, when we take some water and we add sugar or salt, you can see that first initially the water level rises, and after some time they reaches the initial level, isn't it? It means what? Where does it appears? Disappears? Where does this sugar particle disappears? They are getting into the space between the particles. It means that in between the water molecules, for example, if we are taking some water, in between the water molecules there are some spaces, and in between the spaces the sugar or salt particles are getting into the space between these water molecules. So, it means that particles of matter have space between them. That is why the water level remains the same, isn't it? The water level remains the same because those particles are, if we add sugar or salt, those salt or sugar particles are getting into the space between the water molecules. That is why that is the first thing, particles of matter have space between them. The second one, particles of matter have space between. The second one is particles of matter are continuously moving. They are continuously moving. Particles of matter are continuously moving. In order to explain this, if we take an unlit incense stick, for example, agarbadi, unlit incense stick, if you are keeping that incense stick in a corner of your class, will you get the smell of that unlit incense stick? Will you get this smell? No. In order to get the smell, you have to go closer, isn't it? But when we light that incense stick, you can see that that smell will be reaching if you are sitting far away from that incense stick, isn't it? There, it will reach you after some time. If you are lighting that, if you light that incense stick, you will get the smell if you are sitting far away from that. But if unlit incense stick, it will not get that smell. In order to get the smell, you have to go closer to that, isn't it? And then take another example. Take a beaker and take some water in that beaker. Then you add, you take two beakers, okay? You take two beakers, and in both beakers you take water, and in one beaker you add 1 or 2 drops of ink. There is blue or red ink on the sides of this beaker. Drop 1 or 2 drops of ink you add in on the through the sides of the beaker without stirring, okay? And in other beaker you add 1 or 2 drops of honey, 2 drops of honey without stirring. And then after some time you can see that the color, whether it is red or blue ink, the color is spreaded throughout the water. Here also, if we are taking the sample of honey or honey and water, you will get it will be what it is, sweet after some time. So it means what? Whether without stirring, where it goes. So the particles are continuously moving in this. That is why it is spreaded, isn't it? It is spreaded. And take another example. You take 2 beakers, and in one beaker you have to take in both beakers you are taking water, and then in one beaker you take some copper sulfate solution. And so here we have taken 2 beakers. One beaker you take hot water, and in another beaker you take what? Cold water. So you add some amount of copper sulfate into this hot water, and you add the same amount of copper sulfate into cold water. So you can see that hot water, it will dissolve the copper sulfate very quickly, but cold water it takes time to dissolve the copper sulfate solution. So, from these experiments, so what conclusions we can make? The particles of matter are continuously moving, but here in this case what is happening here? In the case if it is hot water, if the condition is hot, then we know the particles, every particles they are having some amount of energy, that is called kinetic energy. They possess energy that is called kinetic energy. So, this kinetic energy will be more if the substances are hot. So, that is heating enhances the kinetic energy, and that is why the rate of intermixing will be more. The rate of intermixing will be more in the case of hot water than cold water. So, that intermixing, the process of intermixing of two different substances on their own, that is called diffusion. That is called diffusion. The process of intermixing of two different substances on their own, that is called diffusion. So, the rate of diffusion increases with the increase in temperature. The rate of diffusion increases with the increase in temperature. So, even though if we are not heating, the particles will intermix. Because if we are adding copper sulfate solution after some time, but it will take more time. If we are not heating, it will take more time to dissolve or to intermix. So, that is in cold water, that reaction will takes place in slow rate, but here in hot water that reaction will be takes place in a speedy way or speedy manner. So, from all these experiments we will make a conclusion that the particles of matter are continuously moving. See, for example, if there is a cooked food is there. So, when we are cooking a food, we will get the smell of that cooked food if you are staying far away from that food, if it is cooked, if it is hot one. But if a cold food, a cooked one, if you are keeping for a long period, and in order to get the smell of that food, you have to reach closer to that food, isn't it? So, that is called diffusion. So, the rate of diffusion increases the increase in temperature. So, the rate of diffusion decreases the decrease in temperature. So, this is the next part, that is particles of matter have space between them, and particles of matter are continuously moving, and the other one is particles of matter attract each other. That is the third property. Particles of matter attract each other. So, that is the another property, another characteristics of particles of matter, not property, characteristics of particles of matter. Those particles of matter attract each other. See, if you take an example, in a classroom, if we divide the students into 4 different groups. In one group, each group contain 6 or 7 members. Okay. So, when these tell them to hold them in their back, just like they are holding, just like dances they are doing, they will hold their hands at their back. So, 7 students they are holding with their hands in their back. So, they will be they are staying at one corner of the classroom, and the other group tell them to hold their fingers like this, or hands, just like their hands they are holding like this, and another group tell them to hold their fingers like this, and the fourth group tell the fourth group to go to those groups and tell them to break those bonds. So, which group will, or those students will, which group is having more attractive power or more power to break? So, these students will experience more power to break will be the first one, that is they are holding their back because they are tightly packed. So, they are tightly packed, that is why they feel more force to break that bonds. And compared to other three, the first one will be having more attractive force between these students, and then the second one, then third one, isn't it? So, the same thing is there. In the case of particles of matter, there are different types of attractive force are there. For example, if you take iron nail, then chalk piece, and then rubber band. So, if you are also provided with one hammer, so when you break these three, iron nail, chalk piece, and then rubber band, which one you feel more difficult to break? It will be iron nail. Why? Because iron nail it is strong, because the particles inside the iron nail are closely packed. The force of attraction between the particles of iron nail is more. That is why you have to apply more force, then only it will break. And what about chalk? It is somewhat by just hammering it will make into pieces, isn't it? And what about rubber band? Rubber band also this rubber band is having more force of attraction than chalk pieces, isn't it? Because by hammering it will not break. So, by stretching sometimes it may break. So, the force of attraction between different particles, they have a different force of attractions, isn't it? So, that is the particles of matter attract each other, and this attraction makes it hard to break. So, different particles of matter have different types of force of attraction. So, these are the different characteristics of particles of matter. Particles of matter have space between them, particles of matter are continuously moving, and particles of matter attract each other. So, these are the different characteristics of particles of matter. I hope you understood. Okay. So, that is all today. And we will discuss the next topics, that is the different states of matter, that will be discussed in the next class, and have a nice day. Thank you.